Reaction identification. Identifying the 7 types of reactions: synthesis, decomposition, combustion, metathesis, single replacement, redox, and other. It is helpful to be able to identify what type of reaction you have if you are going to write the equation for the reaction. We will focus on the first 6 types shown in the previous slide. A strong clue as to the type of reaction can be found simply by paying attention to what the substances are that are reacting, identifying whether the substances are 2 elements, an element and a compound, 2 compounds, or 1 compound, and whether the substances are in solution or not can narrow down the choices considerably. So start by identifying the substances and states of the reactants. Do we have 2 elements? Then it is most likely a synthesis reaction. Do we have an element and a compound? Then it is probably a single replacement reaction. 2 compounds? Then it may be a metathesis or double replacement reaction, especially if it is in solution. Or it might be a synthesis reaction if the 2 compounds are the right ones. A single compound? Then it's probably a decomposition. In an acidic solution? Then it is most likely a redox reaction. An organic compound with oxygen or air? Then it's most likely a combustion. Synthesis reactions produce one product. The synthesis may be from 2 elements or from 2 compounds. In either event, they are generally easy to predict the formula of and to write the balanced equation. Example 1. 2 elements. A piece of lithium metal is dropped into a container of nitrogen gas. The 2 elements must combine to make a compound according to the likely charges of the ions. In this case, they make lithium nitride. The lithium is a +1 ion, and the nitride is a 3- ion, so we get this reaction. Example 2. 2 compounds. There are 3 important types of synthesis reactions that involve 2 compounds. All of them involve oxides reacting. A metal oxide and water will produce a metal hydroxide. A nonmetal oxide and water will produce an acid. A nonmetal oxide and a metal oxide will produce a salt. Metal oxide and water. Solid sodium oxide is added to water. A metal oxide added to water will produce the hydroxide of the metal ion, a base. Here's the reaction. The alkali metal hydroxide is a strong base, and so is dissociated in solution. B. A nonmetal oxide and water. Liquid dinitrogen trioxide is added to distilled water. A nonmetal oxide added to water forms an acid, but the question is often, which acid? The key in this type of synthesis is that the oxidation number of the nonmetal in the oxide does not change in this process. In N2O3, the oxidation number of the nitrogen is +3, so it must be +3 in the product as well. This means the product is HNO2, not HNO3. Since HNO2 is a weak acid, it is not dissociated. C. Nonmetal oxide plus a metal oxide. Solid calcium oxide is heated in the presence of sulfur trioxide gas. A metal oxide and a nonmetal oxide combine to make a salt. The anion of the salt is usually a well-known polyatomic ion. In this case, the sulfate ion. Again, the oxidation numbers do not change. Sulfur is +6 in both SO3 and calcium sulfate. The salt is a solid, so it is not dissociated. Decomposition reactions involve the breakdown of a compound into simpler compounds or elements, often using heat. The driving force of these reactions is often the production of a common, stable molecular substance, such as the gases carbon dioxide, oxygen, sulfur dioxide, or ammonia, or water, which can easily be converted into a gas. There are a number of important decompositions you should be aware of. Metal carbonates and sulfites, metal hydroxides, and acids are the reverse of the three types of synthesis reactions we just looked at. Metal bicarbonates decompose differently from metal carbonates. And hydrogen peroxide is unique enough to deserve a mention. In addition, metal chlorates and metal nitrates should be mentioned. Metal carbonates and sulfites. Powdered magnesium carbonate is strongly heated. The carbonate will decompose, releasing carbon dioxide gas and leaving the solid oxide of the metal. Here's the reaction. Sulfites will decompose, producing sulfur dioxide and the metal oxides. Note that these reactions are the reverse of the synthesis reactions. B. Metal hydroxides. Magnesium hydroxide is strongly heated. The metal hydroxide will release water, usually as a gas, and leave the metal oxide. Again, this is the reverse of the synthesis reaction. C. Acids. Phosphoric acid is heated strongly. When acids are heated, they release water and the nonmetal oxide. These reactions are the reverse of the synthesis reaction between the nonmetal oxide and water. As with the synthesis, the oxidation number of the nonmetal does not change. E. Metal bicarbonates. Solid sodium bicarbonate is strongly heated. Metal bicarbonates, or hydrogen carbonates, decompose in two steps. First, with the loss of water and one carbon dioxide, leaving the metal carbonate. The second step, with stronger heating, is the decomposition of the carbonate into the oxide and carbon dioxide. Hydrogen peroxide. A solution of hydrogen peroxide is heated. Hydrogen peroxide decomposes into water and oxygen gas. Metal chlorates. Solid potassium chlorate is heated strongly. This is the method typically used if you need to make small amounts of oxygen gas in the laboratory. Metal chlorates decompose into the metal chloride and oxygen gas. Metal nitrates. Sodium nitrate is strongly heated. Metal nitrates decompose into the metal nitrite and oxygen gas. Single replacement reactions. Single replacement reactions are simple redox reactions. They will involve an element replacing another in a compound. Metals tend to replace metals and nonmetals to replace nonmetals, though metals can replace hydrogen in acids. The most common nonmetal single replacement reactions involve the halogens. Example 1. Metals. Solid copper strips are added to a solution of silver nitrate. The elemental metal is oxidized to its ion, and the metal ion is reduced to its elemental state. Nonmetals. Chlorine gas is bubbled into a solution of potassium iodide. The elemental halogen is reduced to its ion, and the ionic halogen is oxidized to the element. Remember that the halogens are diatomic elements. You should remember that fluorine and chlorine are gases, bromine is a liquid, and iodine is a solid at room temperature. Both iodine and bromine will dissolve in water a bit. Metathesis reactions involve the interactions of ions in water solution. The ions switch partners and produce new combinations. There are three basic types of metathesis reactions, usually based on the type of products produced. The new compounds may have limited solubility, produce weak or non-electrolytes, or may decompose into gas and water, or maybe just a gas that is not very soluble in water. Example 1. Precipitate formation. Dilute sulfuric acid is added to a solution of barium chloride. Remember the solubility rules to be able to figure out which of the possible products is not soluble. Here is the reaction. Example 2. Weak or non-electrolyte present. Solutions of sodium fluoride and hydrochloric acid are mixed. When weak electrolytes, the weak acids and weak bases, are present, they are not dissociated. Here's the reaction. Example 3. The production of a gas. Hydrochloric acid is added to a solution of sodium carbonate. Acids react with carbonates and bicarbonates, with sulfites and bisulfites, and with sulfides and bisulfides to produce a gas and sometimes water. Bases react with ammonium ions to produce a gas. Combustion reactions are among the simplest reactions to determine the products for. The reactants are some organic compound, a compound of carbon and hydrogen and possibly oxygen, and oxygen gas, and the products are carbon dioxide and water. The difficult part of the question is figuring out the formula of the organic compound. Example: ethine, acetylene, is burned in air. Remember the organic nomenclature to come up with the correct formula for the reactants. Eth means two carbons, and the YNE ending means a triple bond. So the ethine is C2H2. And here's the reaction. Redox reactions are among the most difficult to write and balance, but are fairly easy to identify. Most of the time, the more complicated reactions occur in an acidic solution, and this is specified in the statement of the reaction. We will talk more about redox reactions later in the course. There are a number of other reactions that you need to be aware of. Here's a list of 6. We may discuss instances of these other types at other points in the course.